Welcome back, everybody, for another deep dive. This time, we're going deep on beryllium.
Yeah, beryllium. It's an element I think a lot of people might not know much about, but trust me, it's
Yeah.
way more interesting than it might seem at first glance.
It really is. It doesn't always get the spotlight, but beryllium is a crucial component in so many things. Some of them are cutting-edge tech, and others you might be surprised to find out are really commonplace.
Okay, so let's break this down a bit. What is it about beryllium that makes it so special? Like, are we talking super strength, invisibility, bending the laws of physics?
Well, maybe not invisibility or defying gravity, but beryllium definitely has a unique set of properties that make it really stand out. First off, it's incredibly stiff, but also really lightweight. In fact, it's the fourth lightest element there is.
So it's like the featherweight champ of the elements, but with the strength of a heavyweight.
That's a great way to put it. And on top of that, it has an incredibly high melting point, so it can handle some serious heat. Plus, it's a fantastic conductor of heat, moving that thermal energy around like a pro. Okay, so we've got strength, we've got lightness, and it can take the heat. But is there anything else? What's beryllium's, claim to fame? What's its big ta-da moment?
All right, here's something you might not expect. Beryllium is relatively transparent to X-rays.
Wait, hold up. Transparent to X-rays? Like the kind doctors use to see broken bones and stuff? That's wild.
It is, and that's why it's so valuable in medical imaging. It helps doctors get much clearer, more accurate X-ray images.
So it's not just a strong man. It's got some pretty unique tricks up its sleeve, too, huh?
Exactly. And those tricks make it essential in all sorts of fields, from aerospace engineering to nuclear science. But of course, it's not all perfect. Beryllium does have its limitations, like at room temperature, it's pretty brittle, which makes it kind of tricky to work with.
So maybe not something you want to be playing catch with.
Right. And probably even more important, there are some concerns about toxicity. Inhaling beryllium dust can be dangerous.
Okay. So definitely a handle with care kind of element.
Mm.
It's powerful stuff, but you got to respect its power.
Yeah. Absolutely. Safety first is key when it comes to beryllium. But even with those precautions, its unique properties make it indispensable for all sorts of cutting-edge technologies.
Okay, so where does this wonder element even come from? Is it just lying around waiting to be scooped up?
I wish. Unfortunately, it's not quite that simple. Beryllium is actually a relatively rare element. Now, it is found in over 100 different minerals, but most of those are pretty uncommon themselves. The main source of beryllium is a mineral called beryl. And you might recognize that name because it's the same family that includes gemstones like emeralds and aquamarines.
Wait a second. Emeralds. You're telling me those beautiful green emeralds have beryllium in them?
They do?
So are we talking about, crushing up emeralds to get the beryllium out?
Well, not exactly. It's a little more complicated than that. Extracting beryllium from beryl is a pretty complex process involving multiple steps in chemical separation. And because of those toxicity concerns we talked about, it requires a really careful approach. It's more about refining the beryl or to isolate the beryllium.
That makes sense. Doesn't sound like a DIY project. So we've covered where it comes from, what makes it special. Now let's talk about how it's actually used. What are some of the most notable applications for beryllium?
Well, as I mentioned before, one of the biggest uses for beryllium is in the aerospace industry. It's used to make those incredibly strong but still super lightweight components for aircraft, missiles, even spacecraft.
Wow, so we're talking outer space here. That's got to be some serious strength and resilience.
You got it. It can handle extreme temperatures, pressure, all that fun stuff that comes with being up in space. And remember those X-ray transparent properties we talked about earlier?
Yeah, those are pretty cool.
Well, those aren't just useful in medical imaging. They're also crucial in research facilities like synchrotrons, where scientists use powerful X-rays to study the structure of matter at the atomic level.
So we're talking like unlocking the secrets of the universe, both out there in the vastness of space and down here at the tiniest level imaginable.
Exactly. Beryllium is helping us do both. But it's not all about cutting-edge science and technology. Remember I mentioned how stiff beryllium is?
Yeah, it's no slouch in the strength department, that's for sure.
Right. Well, that stiffness, combined with its lightweight nature, makes it perfect for things like speaker diaphragms and high-end audio systems.
Wait a minute, really? So the amazing sound I get from my audiophile speakers could be thanks to beryllium.
Quite possibly. That stiffness allows the speaker diaphragm to vibrate really precisely, which means it can reproduce sound with incredible accuracy and fidelity.
I had no idea. So it's not just rocket science and X-rays, it's also rock and roll. But beryllium's journey doesn't stop there, right? It's got another big role to play, doesn't it, in the world of nuclear science?
You're absolutely right. When it comes to nuclear science, beryllium really shines, especially as a neutron moderator and reflector.
Okay, neutron moderator and reflector. I'm going to be honest, those terms are a bit over my head. What exactly do they mean, and how does beryllium fit into all of that?
Okay, so imagine a nuclear reactor. That's basically the heart of a nuclear power plant. Inside the reactor, you have nuclear fission happening, where atoms are splitting apart and releasing an enormous amount of energy, and that energy, that's what we use to generate electricity.
Right, I'm following so far. But how do neutrons come into play?
Well, during this whole fission process, neutrons get released. And these neutrons are crucial because they go on to trigger further fission events, basically keeping the process going. But here's the thing. The neutrons that are released, they're moving super fast, like way too fast to effectively trigger those chain reactions.
So they're like, what, tiny little supercharged pinballs bouncing around too quickly to hit their targets?
You got it. That's a great analogy. And that's where the neutron moderator comes in. It acts like a speed bump, slowing those fast neutrons down. And when they're slowed down, they're more likely to interact with other atoms and keep that chain reaction going. And beryllium, with its unique nuclear properties, happens to be excellent at this job.
So beryllium is like a traffic cop for neutrons, making sure they're moving at the right speed to keep the whole reactor running smoothly.
Exactly. It helps create this controlled and sustained nuclear reaction, which is essential for a nuclear power plant to operate safely and efficiently. Now, besides slowing them down, we also need to keep those neutrons from escaping. That's where the neutron reflector comes in.
Okay, so if the moderator's the speed bump, what's the reflector? A fence to keep those neutrons in.
Yeah, you could think of it that way. A neutron reflector is like a mirror for neutrons, bouncing them back into the reactor core. This keeps those valuable neutrons from leaking out, which makes the whole nuclear reaction more efficient.
Wow, so beryllium's playing double duty here, controlling and containing those essential neutrons. That's pretty impressive. But, we talked about the toxicity concerns earlier. So if beryllium's used in nuclear reactors, doesn't that make it kind of dangerous?
You're right to be cautious, and with anything nuclear, safety is absolutely paramount. The beryllium that's used in reactors is carefully contained and handled to minimize any risks. And remember, the main concern with toxicity is inhaling beryllium dust. As long as the proper precautions are taken, beryllium can be used safely and effectively.
That makes sense. It's a powerful tool, and like any powerful tool, you got to know how to use it responsibly. So aside from aerospace and nuclear science, are there any other areas where beryllium really stands out?
Definitely. Beryllium is a key player in the world of high-energy physics research. Think particle accelerators, like the Large Hadron Collider. That's where scientists smash particles together at ridiculously high speeds to study the fundamental building blocks of the universe.
Okay, smashing particles. Now that sounds intense. What does beryllium have to do with that?
Well, particle accelerators have these things called beam pipes. They're basically tubes that guide those high-speed particles around the accelerator, and beryllium is often the material of choice for these beam pipes.
Why beryllium? What makes it so special for this particular job?
It all comes back to those unique properties we keep talking about. First, you've got the strength and lightweight nature, which is essential because you don't want anything interfering with those speeding particles. But there's more to it than that. Some particle accelerators operate at incredibly low temperatures, like just a few degrees above absolute zero. And beryllium stays stable and strong even in those extreme conditions.
Wow, near absolute zero. That's seriously cold. Why is it so important for those beam pipes to function at those temperatures?
Well, most materials, when they get that cold, they become brittle and prone to cracking. Not beryllium, though. It stays tough and intact, making sure those beam pipes can withstand the extreme cold and the pressure. Plus, beryllium is diamagnetic, which means it's not affected by magnetic fields. And that's a big deal because particle accelerators use super strong magnets to steer and focus those particles.
So beryllium's like the ultimate multitasker. It's strong, lightweight, can handle extreme temperatures, and it laughs in the face of magnetic fields. No wonder it's such a popular choice for these cutting-edge facilities.
You got it. It's those qualities that make beryllium essential in pushing the boundaries of high-energy physics research. But wait, there's more. The beryllium story doesn't end there. Its applications go even further, reaching into the fascinating world of optics.
Optics. Okay, now you've really got my attention. How does beryllium factor into optics?
It's all about that stiffness we talked about, its lightweight nature, and the fact that it can be polished to an incredibly smooth finish. These properties make it a really sought-after material for making mirrors, especially for applications where precision and stability are key.
Mirrors. Okay, now I'm picturing a giant beryllium disco ball. But seriously, what kind of mirrors are we talking about here?
Think telescopes, especially space telescopes, like the James Webb Space Telescope, the one that's been sending back those amazing images of the cosmos. Its primary mirror, the one responsible for gathering all that light from distant stars and galaxies, is made of beryllium.
Hold on. The James Webb Space Telescope, the one that's giving us those mind-blowing glimpses into the early universe. So beryllium is helping us peer back in time.
You could say that. Because beryllium is so stable at those crazy low temperatures in space and doesn't warp much as temperatures change, it's perfect for building those incredibly sensitive mirrors. It's what allows these telescopes to work so well in the harsh environment of space.
That is just incredible. It's amazing to think that beryllium is playing such a big role in unlocking the secrets of the universe, from the grand scale of those space telescopes to the microscopic level of particle accelerators.
Exactly. And its journey doesn't end there. Beryllium's unique properties make it useful in all sorts of other areas. For example, because it's non-magnetic, it's perfect for tools and equipment that are used around sensitive magnetic devices, like MRI machines in hospitals.
So beryllium is even helping to keep patients safe during medical procedures. This element truly is a jack of all trades.
It really is. And let's not forget its role in everyday technology. Beryllium copper, which is an alloy of beryllium and copper, is incredibly strong and durable. You'll find it in everything from springs and electrical contacts to non-sparking tools. Those are essential in environments where sparks could be dangerous, like oil rigs and chemical plants.
Okay, I'm adding beryllium copper to my list of impressive alloys. That stuff sounds incredibly useful. But before we wrap up our deep dive on beryllium, I have one more question. What does the future hold for beryllium? With all these incredible properties and applications, are there any exciting new developments on the horizon?
That's a great question. Researchers are always exploring new ways to use beryllium's unique qualities. One area that's particularly exciting is nuclear fusion research.
Nuclear fusion. That's the process that powers the sun, right? Are we talking about bringing the power of the sun to Earth?
Well, that's the ultimate goal, to create a clean and sustainable energy source that basically mimics what happens inside stars. And beryllium, because it can withstand those extreme temperatures and moderate those all-important neutrons, it could play a crucial role in making that dream a reality.
Wow, that would be revolutionary. So beryllium could be the key to solving the world's energy problems.
It certainly has the potential. Of course, nuclear fusion is still an area with lots of active research and many challenges to overcome, but the possibilities are mind-blowing. And beyond energy, scientists are also looking at beryllium's potential in electronics and even in medical applications.
Medical applications.
Yeah.
That's not something I would have expected. How's beryllium being used to improve healthcare?
Well, beryllium has this great quality called biocompatibility. It basically means it can exist in the body without causing harm. That, combined with its strength and lightweight, makes it a really interesting material for medical implants and devices. For example, researchers are looking at using beryllium alloys for orthopedic implants, especially in places where strength and weight are crucial, like hip replacements.
So beryllium could actually help people regain mobility and live more active lives. That's amazing.
That's the goal. And because beryllium's relatively transparent to X-rays, implants made from these alloys would make it much easier for doctors to monitor the healing process. No more implants getting in the way of the view.
That would be a huge step forward in orthopedic care. It seems like beryllium's got a bright future ahead of it. From energy and space exploration to healthcare and beyond, this element is ready to make a real difference.
You said it. It's clear that beryllium is far more than just a minor player in the world of elements. It's incredibly versatile, essential, and its potential is just starting to be explored.
Well, I think it's safe to say our deep dive on beryllium has been a real eye-opener. This seemingly ordinary element is actually a powerhouse with applications that are literally out of this world. And it even touches our everyday lives in ways we probably never even realized.
It's a testament to the power of scientific curiosity and to the importance of always exploring the potential of everything around us, even the things that seem ordinary at first glance.
Beryllium, you have officially earned a spot on my list of favorite elements. From now on, I'm going to look at those sparkling emeralds in a whole new light. But here's a parting thought for everyone listening. If an element as seemingly simple as beryllium can have such a profound impact, what other hidden gems are waiting to be discovered in the vast landscape of the periodic table? That's something to think about as you go about your day. Until next time, keep exploring, keep learning, and keep diving deep.
When we start talking about nuclear science, that's when beryllium really takes center stage. It's a rock star when it comes to being a neutron moderator and reflector.
Neutron moderator and reflector. Huh. I gotta admit, those terms are a little bit out of my depth. Could you maybe break those down for me a bit? What exactly do they mean, and what does beryllium actually do in those roles?
Sure, no problem. Let's start with the basics. So picture a nuclear reactor, the heart of a nuclear power plant. Inside that reactor, you have nuclear fission going on. Basically, atoms are splitting apart, and when they do, they release a tremendous amount of energy. And that's the energy we use to generate electricity.
Gotcha. So far, so good. But where do the neutrons come into all of this?
Right. Well, when those atoms split apart during fission, they release neutrons. And these neutrons are really important because they go on to trigger even more fission events. They're what keep the whole process going. But there's a catch. The neutrons that get released, they're moving incredibly fast, like way too fast to actually trigger those chain reactions effectively.
So like what, tiny little speed demons bouncing around too quickly to hit their targets?
That's a perfect way to think about it. And that's where our friend the neutron moderator comes in. The moderator's job is to slow down those super fast neutrons. It's like a speed bump for neutrons. And when they're slowed down, they're much more likely to interact with other atoms and keep that chain reaction going. And beryllium, because of its special nuclear properties, it just happens to be incredibly good at this.
So beryllium is like a traffic cop for neutrons, making sure everyone's moving at a safe speed to keep the whole reactor running smoothly.
Precisely. It creates this nice, controlled, sustained nuclear reaction, which is what we need for a nuclear power plant to run safely and efficiently. Now, along with slowing them down, we've also got to make sure those neutrons don't just escape. That's where the neutron reflector comes into the picture.
Okay, so if we think of the moderator as a speed bump, what's the reflector? Is it like a fence to keep the neutrons in?
Yeah, you could picture it that way. A neutron reflector is like a mirror, but for neutrons. It bounces them back into the reactor core so they don't just leak out. This helps maximize the efficiency of the whole nuclear reaction because we don't want to lose those precious neutrons.
Wow, so beryllium is working overtime here, controlling those neutrons and making sure they stay where they belong. Pretty impressive. But we were talking about the toxicity concerns earlier. If beryllium is being used inside nuclear reactors, shouldn't we be worried about it being dangerous?
You're right to bring that up, and safety is always the top priority, especially when it comes to anything nuclear. The beryllium used in reactors is very carefully contained and handled. They have all sorts of procedures in place to minimize any risks. And remember, the main concern with toxicity is inhaling that beryllium dust. As long as the proper precautions are taken, beryllium can be used safely and effectively.
That makes sense. Like any powerful tool, you've got to know how to handle it responsibly. So we've talked about its role in aerospace and nuclear science, but are there any other areas where beryllium is a real game changer?
Absolutely. Beryllium is also a major player in high-energy physics research. Those particle accelerators, like the Large Hadron Collider, that's where scientists smash particles together at incredibly high speeds to study the fundamental building blocks of the universe.
Particle smashing. That sounds pretty intense. I'm curious, what role does beryllium play in all of that?
Well, inside these particle accelerators, there are these things called beam pipes. Think of them like tubes that guide those super fast particles around the accelerator. And beryllium is often the material of choice for making these beam pipes.
Why beryllium? What makes it so well suited for that particular job?
It comes down to those same unique properties we've been talking about all along. Firstly, there's the strength and the lightweight nature, which is essential because you don't want anything slowing down those speeding particles. But there's another reason. Some of these particle accelerators operate at incredibly low temperatures. We're talking like just a few degrees above absolute zero. In beryllium, it stays strong and stable even in those extreme conditions.
Wow, near absolute zero. That is crazy cold. Why do those beam pipes need to function in such frigid temperatures?
Well, the problem is most materials become super brittle at those temperatures. They're prone to cracking. But not beryllium. It stays tough. It stays intact, which means those beam pipes can withstand that extreme cold and all that pressure. Plus, beryllium is diamagnetic, meaning it doesn't react to magnetic fields, which is crucial because particle accelerators use super strong magnets to steer and focus those particles.
So beryllium is like the ultimate multitasker. It's strong, it's lightweight, it laughs at extreme temperatures, and it doesn't even flinch at magnetic fields. No wonder it's a favorite for these cutting-edge research facilities.
You got it. Those are the qualities that make beryllium so essential in pushing the boundaries of high-energy physics research. But guess what? The beryllium story doesn't start there. It has even more applications, and some of them might surprise you. We're talking about the world of optics.
Optics. Okay, now I'm really intrigued. What does beryllium have to do with optics?
Well, remember how we talked about beryllium being stiff, lightweight, and able to be polished to the super smooth finish?
Yeah, those are some of his superpowers.
Exactly. And those qualities make it a highly desirable material for making mirrors, particularly for applications where precision and stability are absolutely critical.
Mirrors, huh? Okay, I'm picturing a giant beryllium disco ball. But in all seriousness, what kind of mirrors are we talking about here?
Think telescopes. And not just any telescopes, but space telescopes. Like the James Webb Space Telescope, the one sending back those incredible images of the universe. Its primary mirror, the one that gathers all that light from distant stars and galaxies, is actually made of beryllium.
Wait a second. The James Webb Space Telescope, the one that's giving us those incredible glimpses into the early universe. So beryllium is helping us look back in time.
You could say that. Beryllium is so stable at those incredibly low temperatures out in space, and it doesn't distort much as temperatures change. That makes it absolutely perfect for building the sensitive mirrors that allow these telescopes to work so flawlessly, even in that harsh environment of space.
That is just mind-blowing. It's amazing to think that beryllium is playing such a crucial role in unlocking the secrets of the universe. From the massive scale of those space telescopes to the microscopic level of particle accelerators.
Exactly. And its journey doesn't stop there. Beryllium has so many applications thanks to its unique properties. For example, it's non-magnetic, which makes it perfect for tools and equipment that are used around sensitive magnetic devices, like MRI machines in hospitals.
So beryllium is even helping keep patients safe during medical procedures. This element truly is a jack of all trades.
I know, right? It really is. And let's not forget about its importance in everyday technology. Beryllium copper, which is an alloy of beryllium and copper, is known for being incredibly strong and durable. You'll find it in all sorts of things, from springs and electrical contacts to those non-sparking tools that are essential in environments where sparks could be really dangerous, like oil rigs or chemical plants, for example.
Okay, beryllium copper is officially on my list of impressive alloys. That stuff sounds incredibly useful. But before we wrap up our deep dive on beryllium, I have to ask, what does the future hold for this incredible element? With all these amazing properties and applications, are there any exciting new developments on the horizon?
Well, there's always something new on the horizon when it comes to beryllium. Researchers are always looking for ways to harness its unique properties. One area that has a lot of people excited is nuclear fusion research.
Nuclear fusion, huh? That's the process that powers the sun, right? Are we talking about like bringing the power of the sun down to Earth?
That's the ultimate goal, yeah. To create a clean and sustainable energy source that mimics what happens inside stars. And beryllium, with its ability to handle those incredibly high temperatures and moderate those crucial neutrons, well, it could be a key part of making that happen.
That would be absolutely revolutionary. So beryllium could actually hold the key to solving our energy problems.
It definitely has the potential to play a big role. Of course, nuclear fusion is still a very active area of research with a lot of challenges to overcome, but the possibilities are incredibly exciting. And it's not just energy. Scientists are also exploring beryllium's potential in electronics and even medical applications.
Medical applications. That's not something I would have thought of. How could beryllium be used to improve healthcare?
Well, beryllium has this interesting property called biocompatibility. Basically, it means it can exist in the body without causing harm. And when you combine that with its strength and lightweight, it opens up some really exciting possibilities. For example, researchers are looking at using beryllium alloys for orthopedic implants, especially in places where strength and weight are really important, like, say, hip replacements.
So beryllium could actually help people regain mobility and get back to living more active lives. That's amazing.
Exactly. And because beryllium is relatively transparent to X-rays, implants made from these alloys would allow doctors to monitor the healing process much more easily. No more implants getting in the way of the X-ray images.
That would be a huge improvement in orthopedic care. It sounds like beryllium is ready to make a real impact in so many areas. Energy, space exploration, healthcare. What a versatile element.
It really is. It's clear that beryllium is much more than just a minor character in the story of the elements. It's a vital material, and we're really just beginning to explore its full potential.
I think it's safe to say that our deep dive on beryllium has been an eye-opening experience. This element that seems so ordinary at first glance turns out to be a real powerhouse. It has applications that are literally out of this world, and it touches our everyday lives in ways we probably never even realized.
It just goes to show the power of scientific curiosity, doesn't it? And the importance of exploring the potential of everything around us, even the things that seem the most mundane.
Well, beryllium has definitely earned a spot on my list of favorite elements. I'm going to look at those sparkling emeralds in a whole new light from now on. But here's a final thought for everyone out there. If an element as seemingly simple as beryllium can have such a huge impact on our world, what other hidden wonders are waiting to be discovered in the vast landscape of the periodic table? That's something to ponder as you go about your day. Until next time, keep exploring, keep learning, and keep diving deep.